How's it going? In this video, I'm going to be showing how we can write complex numbers. So, remember my discussion, some of the first videos that I made were talking about how we classify real numbers. Well, there's actually a thing above that called complex numbers, and they span a much more broad audience of numbers. See, with the complex numbers, what it allows us to do is get rid of the problem that we have whenever we go to take roots of negative numbers. Okay, so the problem with the real numbers is there aren't any roots of negative numbers, because if we square negative numbers, then we end up with a positive number. So there isn't anything that we can take the square root of that's going to produce a negative number. So that's the problem that we have to solve here. And we solve that by just saying that the square root of -1 is this number I. Okay, so this is part of the reason why people call I an imaginary number. I don't like the term imaginary numbers because it's not like it's not real. It just doesn't show up in what we call the real number group, just numbers that we use all the time and that can be quantifiable. It doesn't show up there. But they are, in fact, legitimate. They are legitimate numbers, but they're just not a part of the real number group. So they are either called the complex part or the imaginary part. I calling it the complex part because it's not like they don't exist, like an imaginary friend. So the way that we write complex numbers is that there's always going to be a real part, which we call A, and then we tack on this imaginary part called BI. And this BI, this B is a real number that we multiply by I to see how many, how much I's that we have. So in essence, this is what a complex number real looks like. And if you don't have a BI, then you're just left with the real part. And sometimes we have a number that is just purely imaginary or purely complex that does not have a real part besides the I here. So I'm going to go through a few examples on how we can write complex numbers and how we can arrive at complex numbers. So we have 4 plus the square root of -9. So right off the bat, I know that I'm going to have a complex component because I have a negative number inside the root. So in any other context, like in the real numbers, then we would say that this is not a real answer because we can't have roots of negative numbers in the real domain. So the way that we go about this is we can rewrite this number as 4 plus the square root of -1 times 9. So remember that rule. If I have a product of two numbers inside the root, I can rewrite it as the product of the roots. So I have this to work with. And so what I can do is I can say 4 plus the square root of -1 times the square root of 9 here. So now I can use this rule that I have over here to break up this expression into things that I know. So the square root of -1, we just learned, is I. And we know that the square root of 9 is just the number 3. So what I'm left with is 4 plus 3 times I. And we write that as 4 plus 3i. So you see how it's in the form of A plus BI. So we have our real part right here and the complex part right there. So whenever you see a complex number that's written in this fashion, it's called standard form. So this is the complex form, or this is the standard form of how we write complex numbers. So let me go through a few examples to illustrate this point a little bit better. So let's say that I had 3 plus the square root of -16. So again, I can rewrite what's inside of the root here as a product of -1 and 16, because if I multiply these two together, I just get the -16 back. And I'm going to use the rule that I can split this up into a couple of separate radicals here. And I know that the square root of -1 is I, and the square root of 16 is the number 4. So what I'm left with is 3 plus 4 times I. And that's it. So this is how I convert something from the real domain that would not fit in into a complex number that does fit in. So I'm going to do a couple more of these. So let's say that I had I squared plus 3i. So we know that the square root of negative 1 is equal to I. And so that means that I squared is equal to the square root of negative 1 multiplied by the square root of negative 1. And since I'm multiplying it by itself, I'm squaring it. So this is the same as me writing the square root of negative 1 squared. Well, guess what? The root and the squared cancel each other, so what I'm left with is just a negative 1. So I squared gives you negative 1, and this is very interesting because if you square the complex part of the number, you end up getting a real number back. So I know that I squared is just negative 1, so I have negative 1 plus 3i. Now I can't do anything with the 3i, it's already in its standard form, so this is what I have. This is all I'm left with. Alright, I'll go through one more of these. So let's say that I have minus 5i plus I squared. So we just learned that I squared is equal to negative 1. So I'm going to substitute that back in. I have minus 5i plus negative 1. And if I want to convert this into standard form, what I can do is just switch the real and the complex parts with each other. So I have negative 1 minus 5i, and then now this complex number is in its standard form. So the standard form is always a real part and then the complex part following thereafter. So I hope this video was helpful in showing where the imaginary or complex part of complex numbers comes from. It's just a way that we can get around negative roots. So if you have anything inside of the root that's a negative, what you can do is just write that as a product of the square root of negative 1 and the square root of whatever number else you had, because negative 1 times that number in there is just going to give you the negative version of that number. And so we use the tool of I to get around this problem. And in standard form, we always have the real part and the imaginary part there afterwards. So, and also I squared produces a real number. So some very interesting things happen whenever you raise complex numbers to different powers. So I hope this video was helpful in getting a glimpse into how we write complex numbers and kind of where they came from. And stay tuned for the next video.